In this video, you see how to solve equations with variables on both sides. Let's review our guidelines for solving equations. Remember, our goal is we always want to find the value of the variable by getting it alone on one side of the equation. We want to simplify each side of the equation using distributive property or combining like terms. We want to get the variable term alone on one side of the equation by zeroing out the constant on the variable side. In these examples, there'll be variable terms on both sides of the equation, so we are also going to see how to zero out the variable term on one side of the equation. And then we want to isolate the variable. That means we want to make the coefficient 1 by dividing the coefficient or multiplying by its reciprocal. And then we can always check our work by substituting our answer back in the original equation. So let's take a look at a couple examples. 3v plus 15 equals 1 plus 5v. In this equation, we have variable terms, 3v and 5v, on both sides of the equal sign. And the way I want to look at this is I want to zero out the variable term on one side of the equal sign. And I could either choose to zero out the 3v or the 5v, but for me, it always makes more sense to try to keep my coefficient positive. So I am going to subtract 3v from both sides. And again, this keeps my coefficient positive. So 3v minus 3v is 0v, or just 0, and that's a positive 15. And that's equal to 1 plus 5v minus 3v, which is just 1 plus 2v. See, my coefficient remained positive by doing this. If I subtracted 5v on both sides, I'd have a negative 2v, which is not the end of the world, but just may make things a little bit harder. And then I want to eliminate the constant from this variable side now. This is just a two-step equation, which we know how to solve. 14 is equal to 2v. Isolate the variable, divide both sides by 2, and I get 7 is equal to v. So v is 7 here. What I want to do is I want to check my work. Now when I check my work, this is going to be just a little bit different than when we checked it before. So when I check my work, remember v is equal to 7 here. When I check this work, what I'm going to do is I'm going to substitute 7 for v. Oops, that's equal to. And what I should get if I solve this right is both sides of this are going to be equal. So 3 times 7 is 21, plus 15 is 36. And that should be equal to 1 plus 5 times 7 is 35. And that's also 36. These are both equal. If I solved this incorrectly, I would have two numbers here that are not equal here at the bottom. All right, let's see that again. I am going to solve this next equation here. And again, I want to try to keep my coefficient positive. So what I'm going to do is I'm going to subtract 2x on both sides. And I get 1 is equal to 11 plus 5x. And then I'm going to eliminate the constant on my variable side. This is my variable side. 11 is the constant, so I want to eliminate that by subtracting 11 on both sides. I get negative 10 equals 5x. And to isolate the variable, I want to divide both sides by 5. Negative 2 is equal to x. To check my work, I am going to substitute negative 2 for x. So I get 1 plus 2 times negative 2 equals 11 plus 7 times negative 2. And when I solve this out, I get 1 plus a negative 4, which is 1 minus 4, and 11 minus 14. Negative 3 is equal to negative 3, so this checks out. This last example looks a little more complicated, but I'm just going to recall what I know about the distributive property and combining like terms. I'm going to distribute this 2 here. I get 4 plus 2m equals, and then I have some like terms that I can combine here. It's going to be equal to 3m, and 8 plus a negative 1 is a positive 7. And then I just want to eliminate the variable term from one side, and to keep everything positive, I'm going to subtract 2m here. 3m minus 2m is just m plus 7, bring down that 7, and that's going to be equal to the 4 here. And now I just have a one-step equation. I want to zero out the constant by subtracting 7 on both sides of the equal sign, and I get m is equal to -3. There are some special cases when we have variables on two sides, so let's take a look at both of them. Okay. So here again, I want to use the distributive property. I get 21. -3 times -7 is positive 21, and -3 times positive 2p is -6p. And I look at this and I see another -6p and a positive 21 here. So what I can do is I can add 6p to both sides. And then this is curious because I get something that looks like this. 21 equals 21. This is a true statement, but it's sort of weird because you can't figure out what p should be. And the reason is because p is all real numbers, meaning no matter what value I choose for p, as long as it's a real number, I'm going to get the same thing on both sides of the equation. So for instance, if we said p was equal to 4, let's just say. So -6 times 4 is -24 plus 21, that's -3. I could choose 4 here, right? I want to choose 4 here. So 2 times 4 is 8. And then 8 plus -7 is 1. And -3 times 1 is -3. It doesn't matter what I choose for p. I'll get the same answer on both sides. So that's why p is all real numbers. We get that when we get a statement where like both sides of the equation are equal to each other. So that's one special case. And here's another. So when I multiply this, I'm going to use the distributive property here. I get 35 plus 8r equals 8r plus 32. Now what happens when I try to eliminate the variable on one side? I'm going to subtract 8r from both sides. And I get 35 equals 32. Well, that's false, right? These are not equal to each other, right? So what this is saying here is that there is no value for r that will make these two sides of the equation equal to each other. So what we say is, for r, there is no solution. So those are the two special cases. All real numbers when both equations are exactly equal to each other, both sides are equal to each other, and no solution when there's no way to find a value for the variable that will make the equation work. All right, here are some practice problems for you to do on your own. Hit pause and complete them, and then hit play so you can go through the solutions and see if we came up with the same answers. All right, for this first example, I want to combine like terms. 6y minus y is 5y minus 6 is equal to 10 plus 3y. To try to keep my coefficient positive, I'm going to subtract 3y on both sides. I get 2y minus 6 equals 10. I'm going to add 6 to both sides. And I get 2y is equal to 16. Divide by the coefficient, and I get y equals 8. The next example, I'm going to use the distributive property. -4 times 2v is -8v. -4 times a -4 is a positive 16 minus 6. So to simplify this, I get -8v. Positive 16 minus 6 is a positive 10. And that's going to be equal to 10 minus 8v. Okay, I'm going to eliminate the 8v on both sides. And I get one of our special cases. 10 is equal to 10. That's a true statement, so v is all real numbers. I can choose any value for v, and my equation will be true. And this last example, I've got to use the distributive property a couple times here, remembering that that's a -6. So -6 times 4k is -24k. -6 times 5 is -30. And then -6 times 1 is -6. -6 times -6k is positive 36k. And then I want to combine like terms here. 10k plus 4. I'm going to combine like terms on the left side. Negative 24k plus 36k is 12k. And then negative 30 minus 6 is negative 36. And that's equal to 10k plus 4. I'm going to subtract 10 on both sides so that I'll have a positive coefficient here. 2k minus 36 is equal to 4. And I want to isolate my variable, so I'm going to add the constant that's on the variable side to both sides of the equal sign. I get 2k equals 40. Divide by 2 on both sides. K is 20. And that's how we solve equations with variables on both sides.